Swayam Prabha. Digital India. Educated India.
Research methodology. Now we will do in the lecture number 2 a little more detail. This has been divided into 2 parts, part 1, which I will do now. In research methodology, as we had learnt in the previous lecture, it is the most valuable tool to understand the complexities of a problem, disapprove lies or myths, uphold truth, and build on to create knowledge that is reliable and authentic. Conducting research develops a better understanding and enhances decision-making capabilities. Research is important because it expands knowledge, helps solve problems, and drives societal progress across various fields like healthcare, education, and technology. It also builds credibility to encourage curiosity and helps make informed decisions. So what it means that why should we do research? What is so important about everybody trying to do research? Because it is now the need of the hour. Every country is spending a lot of revenue in their research program. Even in India, Make in India, propagated by our Prime Minister, is also mainly to encourage people to do lot of research on their own. And from this vast research program, some good products will definitely come. Encouraging startups to start their business by doing R&D, research and development. That is the need of the hour. Importance of research is in many fields. First and foremost is advancing knowledge. Research is the foundation of new knowledge and understanding, enabling us to learn and discover new things about the world. Second, solving problems. Research helps identify and address problems, leading to practical solutions and improvement in various areas of life, such as medicine and technology. So, you will see that it not only helps in advancing the knowledge, but scientific knowledge or any other kind of knowledge, but it also is aiming at solving some very important problems. Now, for example, I will give you a very simple example of environmental research. Now, we have seen that so much of plastic is littering all over the place. Definitely, we need plastic to transport food items, to transport many other things. But then throwing away in the dustbin doesn't help the problem. We need to now have a concrete research plan to disintegrate these plastic into some valuable product so that it doesn't litter, it doesn't make the environment polluted. At the same time, the use is not completely abandoned. And therefore, it is important to have a concerted research plan for that. So that is why such problems which we see around us in the society, we can think of finding a solution through research. Improving quality of life. Research contributes to advancement that improves the quality of life, from medical breakthroughs to technological innovations. Then comes building credibility. Research can help build your own credibility and make you more convincing when you present your ideas or opinion. So, because when you think of a research plan, there is a genesis why you have chosen this particular problem or question. So, that is where your own credibility is focused. Then, encouraging curiosity. Research fuels curiosity and desire to understand the unknown, leading to further exploration and discovery. Informed decision making. Research provides the necessary information to make informed decision in various contexts, from personal choices to professional setting. So, when we look at the importance of research, we definitely understand that research is also a very, a decision taken primarily based on certain facts why we should do research and the professional approach to solving that problem. Driving societal progress. Research plays a crucial role in fostering technological innovation, revolutionizing healthcare, spurring economic growth, enriching education, and promoting societal progress. Now, if you look at this is a beautiful downward tree which shows the importance of research. It has been stored from study terrain. Now, why I have mentioned that? Because this is not made by me. This is made by somebody else. I am just using this, giving it due respect to the person who has designed this particular tree for making students understand the importance of research. So it says advancing knowledge, social and economic impact, innovation and development, personal and professional growth, problem solving, along with continuous learning and improvement, evidence-based decision making, validating existing knowledge, and preservation of cultural heritage. So all put together, all requires attention, where research input is required every day, every hour, and every time. Because unless and until we do research, we do not know how to preserve our cultural heritage. Unless and until we do research, we cannot have a continuous learning process and improvement. Similarly, whatever is the knowledge that is existing, for example, in Ayurveda, there is a lot of plants which have been identified based on the Ayurvedic concepts to be very good for certain disease remediation. Now, to validate whether that knowledge that is existing has some scientific backing, whether it has some bioactive compounds or not, and its structure activity relationship, trying to synchronize the information, by the help of that, one can validate existing knowledge. Evidence-based decision making. So you have certain evidences from the Ayurveda. I'll take again the same example. And now you are making a decision whether or not a particular plant is really beneficial for a certain disease. So that is based totally on understanding the structure, compound reactivity, and their subsequent activity. Then comes problem solving. Research is also important that you identify a problem and you look for an answer. Similarly, innovation and development. So many startups have come up. Now they have come up because there is a need of the hour that we have to have many things which are developed indigenously in India. And for doing that, we need to research on our own. We can't depend on technologies from US or Japan or Europe. So for that matter, research therefore becomes very important. Of course, advancing knowledge, there is no doubt about it that advancing knowledge is definitely one of the basic criteria for understanding why we should do research. And of course, social and economic impact it is going to have if we are a research oriented country, then the outcome of the research will be definitely beneficial for the societal growth. So, when we now look at these points in a little more elaborate form, we will understand that advancement of knowledge, research contributes to the growth of discipline by generating new information, validating existing theories, and refuting outdated ideas. It helps build a body of evidence that others can use and expand upon. So, first thing is it enhances the knowledge, advancement of knowledge. Now, one basic criteria to do research is that it should add new scientific knowledge to the existing knowledge. Problem solving through research, practical problems in various fields such as medicine, agriculture, engineering, and education can be understood and addressed effectively. It enables informed decision making based on data and facts. So, problem solving is not just that you take somebody's help and you do some concoction, you come to derive to some conclusion without understanding the importance of data and facts. You have to do it in a very systematic manner. Innovation and development are the integral part of scientific development. Scientific and technological advancements are driven by research. Innovations in healthcare, environmental sustainability, communication, and industry often stems from years of methodological research. So, if research is done in a methodical manner, then only innovation and development can take place. Policy formation. Governments and institutions rely on research to create evidences-based policies to ensure that laws, regulations, and public programs are grounded in reality and are more likely to be effective. So, based on research, many new policies are formed because that is what is the advantage and importance of research. Education and critical thinking. Engaging in research enhances analytical thinking, problem solving skills, and intellectual curiosity. It forms a core part of higher education and academic training. Economic growth. Research fosters industrial development and economic progress by supporting the creation of new products, processes, and markets. R&D, that is research and development, is a cornerstone of global competitiveness. What it means, cornerstone means it is one of the pillars. Any country globally cannot be in competition with the rest of the world unless and until there is a strong research and development scheme running in that country. So it is directly connected to the economic growth. Improved quality of life. Medical research has led to life-saving treatments improved healthcare, and increased life expectancy. Similarly, social science research has helped in understanding and improving social systems. So, in either ways, whether it is medical research or social science, it is affecting our life and the quality of our life. Informed citizenship. In a world filled of misinformation, research promotes critical inquiry and helps individuals to become informed citizens capable of understanding complex societal issues. So here also, it is very important to understand that even the general awareness in the society comes from research. Because people are publishing in newspaper, lot of news comes that this has been developed, that has been developed. People read it, and even a non-scientific person can make sense out of the research, thinking that it is important and it is for the development of societal issues. So, what is research methodology? In the last 1.5 hours, I have been talking about only research methodology. Let us try to understand and understand with its full meaning. Research methodology is a specific procedures or techniques used to identify, select, process, and analyze information about a topic. In a research paper, the methodology section allows the readers to critically evaluate a study's overall validity and reliability. That means you have different sections. First you have the title, then you have abstract, then you have introduction, and then you have materials and methods. So in the material and methods section, the entire process which you have followed in your research is enlisted. Becoming familiar with the research methods used by an area of study allows you to understand it more effectively, because many different types of research designs can be used. This is especially important for the study of human growth and development. Different research methods also have different levels of validity. Types of research methodology. We have just in the last lecture we had studied this, but now since we are going into details and getting some new terms to learn, there are many types based on methods for information and data collection. Based just on what is the method related to information and data collection, we can have research methodology which could be observational, experimental, simulation, and derived. So these are the 4 categories which are very important to understand from the information and data collection heading. Types of research data. The type of research data you collect may affect the way you manage that data. For example, data that is hard or impossible to replace, that is the recording of an event at a specific time and place, requires extra backup procedures to reduce the risk of data loss. So now, depending on whether you have a data which can vanish or disappear, there has to be a backup system also. Or if you are noting down an experimental condition, that copy should be available, that writing should be legible, and it should be accessible to the other researchers of the same research group if required at a later period of time. Or if you will need to combine data points from different sources, you will need to follow best practices to prevent data corruption. So if you're putting the data on the computer, there you have to prevent it from virus infection or any kind of data corruption, and therefore the source and the computer has to be having a virus affecting data or software which can take, and there are many such there are many such softwares available which can be made use of. In research methodology, data collection involves gathering and measuring information on variables of interest to answer research questions, test hypotheses, and evaluate outcomes. Broadly, data collection methods are categorized as primary and secondary, with further subcategories. Primary data collection involves directly gathering information from the source, while secondary data collection uses already collected data from existing sources. So, depending on what is the scenario, you will take care of all the use of research data in the most correct manner, whether it is primary data collection source or whether it is secondary data collection source. Now, observational data. Observational data are captured through observation of a behavior or activity, as the name suggests. It is collected using methods such as human observation, open-ended surveys, or the use of an instrument or sensor to monitor and record information, such as the use of sensor to observe noise levels at the megapascal or St. Paul airport. So, you will see that these informations are very, very important. In an airport, there is so much of noise pollution. So, how much of the noise level has gone up, how to cut down that noise level cannot be just done randomly. It has to be done in a very scientific and in a manner which under proper research observations. Because observational data are captured in real time, it would be very difficult or impossible to recreate if lost. Now, a noise at an airport at a particular time cannot be replicated. So, this information has to be preserved very carefully. Observational data in research refers to information gathered by observing and recording phenomena in their natural environment without manipulating variables. This method is used to study behaviors, events, and relationships, providing insights into real-world situations. Observational studies can be descriptive, focusing on detailing characteristics, or analytical, investigating relationship between variables. So it could be of a variety. Now what it means is that whenever there is observational data, the treatise of that observational data is also very important to get the right kind of information from that data, whether it is recording, whether it is observing. It has to be analytically analyzed, and what are the variables that were taken into consideration also become a very integral part of the observational data. Key aspects of observational data. Non-experimental. Researchers observe, record data without manipulating or intervening in the situation. Natural setting. Data is collected in the environment where the phenomena naturally occurs. Qualitative or quantitative. Data can be descriptive, qualitative, or numerical, quantitative. Diverse application. Observational studies are used in various fields like social sciences, health research, and environmental sciences, and many other fields. This is just to enumerate a few of them. So you understand that every time one need not do experiments on the bench. Sometimes it is just observational data. Sometimes it is in the natural setting. That is, I gave an example of the noise in the airport. Now that noise can rise up at a certain time in the daytime. It can be very low, it can be tolerable, it can be intolerable at a given period of time. Similarly, the qualitative and the quantitative have been described. Now, what are the advantages of this observational data? Real world context captures data in its natural setting, providing a more accurate view of the phenomena. Now, the noise level at St. Paul's Airport at a given period of time, on a given date, at a given situation, at a given section was so and so. Now, it is very, very specific of a real time context. It is also cost effective, often less expensive than experimental studies, especially for long term research. Exploration and hypothesis generation can help explore phenomena and generate new hypotheses for further research. So, what happens is that when a particular situation arises, the exploration gives rise to new hypotheses because something has been observed which was not observed earlier because nobody did that research before. So now the sensitivity of the people and its related research also plays a very important role. But it has its own limitations. Causality. Observational studies cannot establish cause and effect relationships as variables are not manipulated. So sometimes it is what is the cause, why that effect has happened was very momentary and it cannot be drawn into a graph based on certain manipulated variables. So it has to be a real-time research, real-time data, which was observed at that spur of the moment. Observers' bias. Observers or researchers' biasnesses cannot affect data collection and interpretation. I cannot think that I'm hearing it loud, but others are not hearing it loud. That is my research approach is a little biased. I'm a little more sensitive than others. The noise levels are tolerable. So that is the kind of understanding that one has to have. Ethical consideration, ensuring privacy and confidentiality when observing individuals in their natural setting. So when they are in their natural setting, what is the consideration that one has to make? Only through observation and nothing else. That is its limitation, because you cannot simulate or stipulate. It has to be in that particular given time, what was the situation and how it was observed. Whereas in experimental data, the story is completely different. Experimental data are collected through active intervention by the researchers to produce and measure change or to create difference when a variable is altered. Experimental data typically allows the researchers to determine a causal relationship and is usually projectable to a larger population. This type of data are often reproducible, repeated by others. So, experimental data doesn't have so much of variation. If it has been done in a proper manner, another person can repeat that and get the same data, which means that it is repeatable and it is reproducible. Experimental data in the context of research methodology refers to data collected through controlled experiment designed to investigate cause and effect relationship between the variables. Researchers manipulate independent variables, measure their impact on dependent variables, and control for extraneous factors to draw valid conclusions about the relationship between the variables. This method is particularly useful for testing hypotheses of and establishing causal relationships. So that means in experimental data, there is no scope for any manipulation. Everything is through measurement at a given set of variables, and it is dependent on those variables. If you change the variable, the data will change, not otherwise. Key aspects of experimental data in research methodology. Controlled environment. That means it has to be done under the same condition. Experiments are conducted in controlled environments where researchers manipulate independent variables while keeping other factors constant to isolate the effect of variables being studied. Manipulation of independent variables. Researchers actively change or vary the independent variable to observe its effect on the dependent variable. So, there are variables which are independent, there are variables which are dependent. So, every time it is possible to change the variable, manipulate only the independent variables, not the dependent variables. I'll give you an example at a later stage, but for now, you understand that independent variables can be manipulated, whereas dependent variables have to be correctly measured. The dependent variable, which is the outcome or effect, is measured to determine the impact of the manipulated independent variable. Control of extraneous variables. Researchers aim to minimize or eliminate the influence of extraneous variables that could confound the results and provide a more accurate assessment of the relationship between the independent and the dependent variables. So, in a research methodology, the experimental data is very, very tactfully dealt. Types of experimental design. Various experimental designs exist, including true experimental design, quasi-experimental design, and pre-experimental design. Now, what does these terms mean? That means what you are going to do is your true experimental design. Quasi-experimental design, you're not very sure, so you will try one or two methods and see which one goes. The pre-experimental design is that you take certain precautions and you do some experimentation before getting into the true experimental design. So there are very little but very discrete changes, and understanding of that is very important. Key aspect to experimental data in research methodology. Now, establishment of causal relationships. The primary goal of experimental research is to establish causal relationships between the variables. whether I want to keep the temperature pressure as variable, or I want to keep the yield and temperature as variable, or whether I want to keep the cold solvent and hot solvent as variable, whether I want to take the solvents as different variables. These are up to me. But I have to maintain a causal relationship with what I am changing with what. Meaning that one variable directly influences or causes a change in another variable. Data analysis. Experimental data is analyzed statistically to determine the significance of the observed effects and to draw conclusions about the relationship between variables. So, this, as I told you in my earlier lecture also, that data analysis is the most crucial part of the result inference. You cannot draw a conclusion unless you understand the relationship between the variables, why you were changing them, what was that was prompting you to change the variables, and so on and so forth. And then comes the reproducibility. Well-designed experiments can be replicated by other researchers to verify the findings and ensure the reliability of the result. See, I have done an experiment, I have written down in my paper, and then if you want to repeat that, if I have not given all the minor details, you will not be able to repeat the experiments and will not get the same result, which means that I did not do a good job by putting the well-designed experiment actually in details, and therefore the reproducibility of the results was jeopardized. Now, looking at this, see, pre-experimental research design, true experimental research design, and quasi-experimental research design. These are the types of experimental research designs, and this I have sourced from Question Pro, making you understand that before true experimental research design, we need to go through some pre-experimental research design. For example, I will explain that suppose if I am dyeing a silk material, I will first do a dyeing at, say, a given condition and see how much is the dye uptake. And I see that the silk has not taken much of the dye. So that is a pre-experimental research design. Now in the second time, I'm actually now going to do it as a research project. So I will take a certain amount of dye at a given temperature. I will keep it for certain time period of dyeing, and that is the two experimental research design. Now in the quasi, I am trying to change one or two variables just to see whether any improvement has taken place or not. So that is the kind of difference that each one shows. Pre-experimental research design is the simplest type of experimental research design in which a researcher studies the effect of a treatment or intervention without proper control of groups or randomization. It is usually used in preliminary or exploratory studies to observe possible relationships between the variables. This is exactly what I explained in the previous slide, that you are just trying to understand whether this will happen or not. It's more like preliminary work and exploratory work. It is not going into the actual science. You're not doing it properly in the methodological manner. So therefore, it is just for understanding that based on these studies, pre-experimental research design, you can now plan your variables for the true experimental research design. So pre-experimental design involves manipulating one variable, that is independent variable, to see its effect on another variable which is dependent variable, but it lacks strong control over external variables. Because of this, the results may not be fully reliable. So what it means, that you saw that silk dyeing took place with a new dye. But how much of dye depth, what is the best result that I can get, all that cannot be concluded from this. Pre-experimental design, research design actually involves, it is a characteristic of the pre-experimental design, no random selection of subject, often no control group, simple and easy to conduct, and used for pilot or initial research. So initial research is what is most important inference from the pre-experimental design research. So because, see, somewhere you have to start, and in order to start, whether or not it will go or not, to really plan the true research design, you need to make some small experiments, whether or not it is happening. If it is happening, then of course you set the independent variables, the dependent variables, the conditions, and all of that. How much dye you should take, how much fabric you should take, whether the fabric should be ready to dye or not, whether it can be, gray fabric, and all of that. All the forthcoming decisions are based on the observations made in the pre-experimental research design. Limited ability to establish cause-effect relationship. So from this you cannot actually come to an effective relationship between whether or not it gives a broad idea, yes, it will happen. Now for it to happen in the best manner, you have to go through the true experimental research design. So types of pre-experimental research design is one-shot case study, where in this design a group receives a treatment and then the outcome is observed. So it is structured that, whether you do a treatment and you see the observation. Simple, one shot. Second is one group pre-test, post-test design. The same group is tested before and after the treatment. That means you did a pre-treatment, then a treatment, and post-treatment. So, pre-test, treatment, and post-test. Measuring dye uptake of a fabric before and after applying a chemical auxiliary. Then comes the third, static group comparison. Two groups are used, but no random assignment is done. Group 1, just treatment and observation. Group 2, no treatment and seeing the observation. So these are kind of pre-treatment, types of pre-treatment, pre-experimental research design. Now, pre-experimental research designs have their advantages and limitations, like any other situation. So, advantages are, they are simple, inexpensive, easy to conduct, useful for pilot studies, help researchers explore new ideas. Whereas limitations are lack of control over external variables, results may be less reliable, weak evidences for cause and effect relationships. Nevertheless, pre-experimental designs are important. So conclude, pre-experimental research design is mainly used in early stages of research to gain preliminary insights, but it has limited scientific rigor compared to true experimental designs. So I have just mentioned that a while ago, that it gives an idea whether a process will take place or not. But the effective happening of that process can be only found out from true experimental designs. Coming to the next part is the true experimental research design. True experimental research design is a type of research design in which the research manipulates the independent variables such as using a control group and a randomly assigned subjects to groups in order to establish a clear cause and effect relationship between the variables. So here you are actually now seriously doing a research where you are keeping all the control groups into consideration and trying to find out the cause and effective relationship between the variables. Meaning of true experimental research design. In true experimental research design, the researcher conducts experiments under controlled conditions to determine whether a treatment or intervention causes a specific effect. It is considered the most reliable and scientifically rigorous research design. So this is what is most reliable, on which one can actually publish and you can get real data out of it. True experimental research design have certain key characteristics. Manipulation. The researcher changes or controls the independent variables to observe its effect on the independent variables. For example, changing dye concentration to study its effect on color strength. Control group. A control group is used for comparison. This group does not receive the treatment. For example, experimental group will be fabric is treated with auxiliary and the control will be fabric is not treated with auxiliary. Then only you can compare whether the auxiliary actually made any difference. Otherwise, it is very difficult to ascertain and assess both whether the control group was making any difference. Randomization. Subjects or samples are randomly assigned to experimental and control groups. This reduces bias and ensures fairness. So when you do randomization, then you know that yes, the experimental conditions for a certain control groups were optimal. Quasi-experimental research design. Quasi-experimental research design is a type of research design that examines the effect of an independent variable on a dependent variable, but without random assignment of subjects to groups. It is used when true experiment design is not practical or possible. So you try to do certain randomization and you try to find out some facts about an experimental research design. What is the meaning of quasi-experimental research design? In quasi-experimental design, the researcher introduces a treatment or intervention, but the participants are not randomly assigned to experiment the experimental condition or the control groups. The groups usually already exist, and this is more from the social science of research. So characteristics are manipulation of independent variables, no randomization, often includes a comparison or control group, and used in real life or field setting. Moderate levels of control over variables. So there are certain parameters under which this is also used for a certain set of research designs. Simulation data. Simulation data are generated by imitating the operation of a real-world process or system over time using computer test models. For example, to predict weather conditions, economic models, chemical reactions, or seismic activities. And today's time we see weather reports of all over the place globally, we get to know through this kind of simulation data. This method is used to try to develop and determine what would or could happen under a certain conditions. The test model used is often as even more important than the data generated from the simulation. So it is in a way very important, but it is not the real situation. Simulation data or synthetic data in research methodology involves creating artificial data set that mimic real world scenario or processes. It is a valuable tool for testing models, algorithms, and hypotheses, particularly when real data is scarce, expensive to collect, or poses ethical concern. So simulation has its own importance. It is not that we are concocting, but many a times it is difficult to collect data, it is very expensive, or the real data is very scarce, or possessing ethical concerns, like if you are trying to find out the radioactivity, it is more based on the simulation data than the real data. Simulation data or synthetic data. Synthetic data means simulated data in artificially generated to resemble real world data or potential future scenarios. And the purpose is, it is used for various purposes, including algorithm testing, model validation, experimentation, data augmentation, and privacy preservation. Now, algorithm testing means what? That evaluating the performance of a machine learning algorithm under different conditions. In today's time, there is a lot of AI that is happening, machine learning. It is a part of that. It is based on an algorithm. Model validation, checking the accuracy and reliability of statistical models or simulated models. Experimentation, exploring different scenarios and hypotheses without the constraint of real-world data collection. Or data augmentation, which means that increasing the size and diversity of existing data sets. Privacy and preservation, in creating synthetic data that preserve sensitive information while allowing for analysis. So it is a complete, information set which is generated through algorithms to check whether this model is valid or not, and so on, and whether this can be scaled up. Today it has been done for one city. Tomorrow can it be done for the whole state, and so on. Techniques to generate simulated data. Creation methods. Simulation data can be generated using various techniques, including statistical models, drawing data points from known probability distributions, computational models, which is based on simulated complex system using algorithms and rules, and generative adversarial network, that is GAN, creating synthetic data that closely resembles real data, mutation algorithms, modifying real data to generate new instances. So much can be done through such techniques of simulated data management that a new kind of data set can be generated, and which is very close to the real live data. So what it means, that this simulated data also, in today's world, in computational research, people who are doing developing many softwares and hardwares are taking help of this simulation data in a very, very big manner. What is the use of simulated data? Cost and time efficiency. Simulated data can be generated quickly and at a lower cost than collecting real data. Controlled environments. Researchers can control the characteristics of simulated data, ensuring specific features or distributions that are present. Ethical and legal considerations. Simulation data can be used in situations where real data collection raises ethical or legal concern. Data completeness. Simulation data is typically complete, unlike real data, which often has missing values or inconsistencies. Testing and validation. It allows researchers to test and validate analytical systems or model under idealized conditions. So what it means that this is not only cost and time efficient, it can be done under controlled environment. It is sometimes there are limitations of ethical and legal matters. There also simulated data can be done very effectively without crossing those limits. Data completeness. Sometimes the real data are not complete or are not inconsistent. So consistencies are very questionable in terms of real-time data. But here in simulated data, we have no such problem about that. And if suppose somebody has developed a software to be able to test and validate, you need simulated data to do so. So examples of simulated data in research. It can be medical simulation, simulating patients' condition to train healthcare professionals. Engineering simulation, modeling processes or system to optimize performance or identify potential issues. Business simulation, modeling markets or business environments to test strategies or predict outcomes. Computer science, simulating network traffic, security threats, or other complex systems. Social science, simulating social interactions or behavior to study social dynamics. So it can be actually applied to so many fields like medical simulation, engineering, business, computer science, social science, in all types where modeling and process development is based on those models are actually the main criteria. Therefore, we can say that even simulation data has a lot of big role to play in today's research world. Consideration, validation. The simulated data must accurately reflect the real world phenomena being modeled. Accuracy, the simulated model should be accurate enough to capture the key features and relationships of the real system. Interpredictability, researchers should be able to interpret the simulated data and its implication for the real world context. Reproducibility, the simulation process should be reproducible, allowing others to verify the results. So in conclusion, we can say that simulation data is a powerful tool for research, offering flexibility and control that can be invaluable in a variety of scientific and practical applications. So it is as important as experimental data. Derived data and compiled data. These are also a part of the simulation process. Derived data involves using existing data point, often from different data sources. For example, combining area and population data from Twin Cities metro area to create density data. In research, derived data refers to new data creating by processing, transforming, or combining existing raw data set. It is not simply a reformatting of original data, but provides new insights by analyzing and cross-referencing different data sets. For example, combining demographic data with purchasing habits can reveal insights about buying behavior by an age, gender, or educational levels. So there are many examples of the derived data, calculating a new variable like annual income or monthly income. And the process is very simple. You are just including extraction, reconstruction, annotation, summarization, and so on. And the purpose is to create derived data to get new information, uncover patterns, and make predictions that were not really available in the original data. So there are derived variables, there are derived variable data set and derived data elements. So we understand that there is an importance of derived data as well. Derived data allows the researchers to gain deeper insight into complex phenomena, test hypotheses, develop new research questions, identify patterns and trends. So with this, we come to an end. To conclude, I will say that in conclusion, research is the backbone of progress in every field of human endeavor. It fuels innovation, support, information decision making, and contributes to the overall development of society. Whether in science, technology, social science, or humanities, research play a vital role in improving quality of life, shaping policies, and fostering sustainable development. Thank you.